Okay, so hidden inside our walls, working around the clock, are two of the most important safety features in your home, grounding and bonding. Now, a lot of people use those words interchangeably, but they actually do very different and very critical jobs. So let's break down what they do and why you absolutely 100% need both of them working together. And it all kind of starts with a question about something we see every single day, that third prong on an electrical plug. We all know it's there for safety, right? But how? What is it actually doing? Well, stick with me because you're about to find out exactly what its role is and how it connects to the entire safety system protecting you. So before we can really get into the solution, we have to appreciate the problem. Electricity is amazing, but it has one simple goal. It's always trying to get back to its source, usually the ground. When everything's working right, it stays on the path we designed for it. But when something goes wrong, when that power escapes, it immediately becomes a huge risk for shock and fire. Right, so think about your wiring like a racetrack, a closed loop. Power flows out on the hot wire, powers your coffee maker or whatever, and then goes back on the neutral wire. Simple. A fault is when there's a crash on that racetrack. A wire gets loose, it touches the metal body of your toaster, and that loop is broken. Now, that electricity is looking for a new way home, and it will always take the easiest path it can find. Our job is to make sure that path is never, ever through you. So to protect us, we have these two different systems, grounding and bonding. And as you can see here, they have very different jobs. Grounding is all about giving big external power surges a safe path to the earth to protect your equipment. Bonding, on the other hand, is about connecting all the metal stuff together to protect you and to make your circuit breaker actually work. Let's dig into each one. First up, let's talk about grounding. I like to think of this as your home's giant shield. Its main purpose is to defend your entire system from massive, dangerous threats that come from outside your house. And honestly, the name says it all. Grounding is a literal, physical wire connecting your electrical panel directly into the dirt, into the earth. Its whole reason for being is to give these huge, dangerous surges of electricity a safe place to go and just disappear, instead of frying every single thing you have plugged in. A really good way to picture this is like one of those runaway truck ramps on a steep highway. When there's a massive electrical accident, like a lightning strike hitting a nearby power line, the grounding system is that big, wide-open exit ramp. It lets all that crazy energy safely get off the highway and dissipate into the ground where it can't hurt anything. So how does it work? Well, this system has three main parts. You've got the grounding conductor. That's the green or sometimes bare copper wire you see. All those wires come together at the grounding bus bar, which is basically a central hub in your main electrical panel. And finally, that bus bar is connected to the grounding electrode, and that's usually a big 8-foot-long metal rod that's hammered deep into the ground right outside your house. So the main thing to remember is that grounding's job is to handle the big stuff. We're talking about dissipating the unbelievable energy from a lightning strike, handling power surges from the utility grid, and just generally keeping your whole system's voltage stable by using the earth as a reference point. Okay, so if grounding is the big shield protecting the whole house, then bonding is your personal bodyguard. Its job is much more up close and personal. It's there to protect you from getting shocked by the stuff inside your home. And the definition here is super important. Bonding is just connecting all the metal things that aren't supposed to carry electricity, like your water pipes, your appliance casings, metal conduit, all together with a wire. The crucial detail here is that they're all being connected to each other. So why do that? What's the point? The goal is to create something called an equipotential plane. It sounds super technical, I know, but all it means is that every metal surface you can touch is at the exact same voltage. And if there's no difference in voltage between the metal faucet and the metal dishwasher you're touching at the same time, then electricity has no reason to flow through you. No voltage difference, no shock. It's really that simple. But wait, bonding has another job, and this one is the real game changer. It's actually the true hero responsible for tripping your circuit breaker when there's a fault. You know, a lot of people think the earth itself does this, but ground is usually a terrible conductor. So how does bonding make it happen instantly? Let's walk through it. This is brilliant. First, a fault happens. A hot wire comes loose and touches a metal water pipe. Now, because that pipe is bonded, it creates this incredible, low-resistance superhighway for that electricity to race right back to the electrical panel. This causes a massive, instantaneous spike in the current, way more than the circuit is designed for. And finally, the circuit breaker sees that huge surge and, click, it trips in a fraction of a second, cutting off the power before anyone can get hurt or a fire can start. And just so we're clear, this isn't just a good idea. It's required by the electrical code for all sorts of things. We're talking metal water pipes, gas lines, the steel frame of a building, all the metal electrical boxes, and especially around swimming pools, where everything from the ladder to the steel rebar inside the concrete has to be bonded to keep everyone safe. So, we've got grounding, the shield, and we've got bonding, the bodyguard. But here's the most important part. Neither one of them can do the job alone. They aren't effective by themselves. True electrical safety only happens when they work together as a team. You know, the best analogy for this I've ever heard is Batman and Robin. Grounding is Batman. It's the ultimate protector, handling the huge catastrophic threats from outside, like lightning. Bonding is Robin. It's right there in the fight with you, working up close to handle the immediate internal dangers, making sure you don't get shocked and creating that path that allows the circuit breaker to save the day. And this isn't just theory, it's the law. OSHA, the agency in charge of workplace safety, has a rule that says this entire safety path, the whole system, shall be permanent and continuous. That means it has to be a completely reliable, unbroken chain of protection, from the appliance all the way to the earth. So if you take away just one thing from all this, let it be this. Bonding is what ties all the different metal pieces together into one single, safe network. And then grounding is what gives that entire network its final, safe escape route to the earth. They're two parts of the same life-saving system. And that brings us full circle, right back to that third prong on your plug. That little prong is the critical link that connects your appliance to both the bonding network and the grounding system. It makes sure that if a fault happens, your guardians are ready to spring into action. So that leaves us with one last question to think about. You know your home's electrical system has these guardians, but are you sure they're actually working together?